I'm Rajiv Iyer. I'm a senior director at RUCKUS Networks. Today we'll be talking, in this section, be talking about RUCKUS Analytics. RUCKUS Analytics is a cloud service, and we started out solving the problem of network analytics and assurance, which is the way we started, but we have moved way beyond that. And one of the directions that we've gone is just let our customers be our guide. So that theme about purpose-driven that we really took to heart. So what we found in our public deployments, large public venues, train platforms, really rugged deployments, was we were having real trouble in seeing how our partners were troubleshooting. These were large service providers, and their deployments were really challenging. And the challenge came not so much as saying we don't understand what is deployed here or we can't control, but what was the challenge here was there was no normal amount of failures. There was nothing normal about failures in these different deployments. What would be normal in one environment would be very different in, let's say, a different environment. I'll give you an example. A train platform, peak hour, versus an enterprise network, completely different. Even a train platform at peak hour versus a non-peak hour, very different. So we needed a different way of thinking about that problem. On that left-hand side, there is a traditional NMS way of dealing with this problem, thinking about events, alarms, threshold crossing alarms. They don't work. If you want to be realistic about troubleshooting these networks, you have to think about the problem differently. And the way we thought about it was an intelligent solution that takes an event and thinks about it a little bit, puts it in context. Is this event really important? Is this transient or it will go away by itself? If it is transient, then we don't worry so much about it. But if it is causing more damage to the network, how much damage? Is this event so bad that I need to wake up somebody right now? Is it worth IT teams' attention? This is a big problem, okay? It's not very easy to find out what is worth IT teams' time. So you figured out an anomaly, all great, but how big an anomaly? Can you compare anomalies? Some failures actually cause other failures. And you don't want to be in a position to tell people you have 17 problems when you have only 2. Some problems cause other problems, and you just have to watch over time. Some failures repeat themselves over time. So you don't want to say, okay, hey, I've been watching the network for the last 1 hour and we saw 10 different failures. Maybe it's a periodic failure. So you need to make those hard decisions. And there we turn to some of the more sophisticated algorithms that have become more common in the last 3 or 4 years. So time series data is, you definitely need it. Without that, you're really not able to do much with it. So every client connection from every AP, every controller is fed into this data pipeline that's ingested. And then you need to look at it from different lenses. Where is the problem happening? When is the problem happening? Look back on what is happening. Plus, you need to also put some context around whether it's outdoor deployment, indoor deployment, everything that we collectively in this room know about RF needs to go in that algorithm to try and build something of a human brain, trying to capture some of that complexity in those algorithms. So that brings us to phase 1 of these things, where we say, okay, we've got a semblance of anomaly scores. Fine, I know what's an anomaly. This is a bigger anomaly versus that's a less big of an anomaly. Anomaly is really a deviation from the normal behavior, but we gave it some context. We have some language to talk about it. Next is actually the bigger and the harder problem. This one is really saying, I now know the anomaly, but I need to still answer the question, is it worth IT team's time? If I tell the IT that there's a problem you need to solve, how do I tell you need to solve this one first and not that one? So this is really the problem that we were trying to solve, and turns out that we needed to use what we are calling knowledge graphs. And knowledge graphs is really about us trying to make sure that we can teach these algorithms wireless LAN. or RF, right? So we understand the dependencies of what's causing what. It's really a graph, and it's linking everything's. Some are just symptoms, some are just root causes. So the knowledge graph engines, complex event processing, those are again things that are helping us learn whether this anomaly or this problem failure is a new failure or is a continuation of an old failure. Analytical engines, decision trees all factor in. Finally, we end up with what's called the insight or an incident there. This is really the money where we want to get to. We want to know what's the impact of the network, what's the severity score, which incident should the IT team solve first, and what is the root cause and recommendations if we can provide some of that. So that is what we have been trying to work. That's the demo that I'm going to show you in just a little bit. But before that, just a little preload here. Incidents and insights, we'll talk about that. We moved beyond that to what we are calling an explainable AI engine. So we are getting all that data and we are able to do something with it and moving beyond just incidents and insights. That's an explainable AI. We'll see that in action. Then we'll move into a little bit of automation. This is AI ops world here. What we're trying to solve here is, can we reduce human toil? Can we say the site reliability engineer, networks ops engineer, can he do something by taking this data and connecting it to the data, tools that they're using? So if I'm able to automate some of those workflows, more power to the IT engineer. And really, it's really about reducing errors. It's a human endeavor at the end of it. And the last part, I think, requires a little bit more introduction. This part is very different from the other three pillars that we talked about. This goes back a little bit more to our purpose-driven part. I'll give you an example. This goes into the business intelligence part of it. And the example would be something like, in our daily lives, we have all seen brands, KFC, Pizza Hut, we know these brands. But these brands are also owned by a parent brand, Yum Brands. So it's probably not very well known fact, but it is known by the same brand, owned by the same brand. Now, the brands have an interest in knowing how their sub-brands are doing. The property owners, meaning if I go start Pizza Hut tomorrow, I have a stake into just making that a profitable enterprise, but I want to run it up effectively. Maybe there are thousands of these locations, but Yum Brands as an entity wants to make sure that globally I have visibility into this data and my customers are happy and the network is performing well and they're following brand guidelines. We have a lot of customers that actually have these franchisee relationships. So we thought about a problem from their end. So it's sort of using the data that we have to make it more operationally effective and helping the line of business decision makers with that data. Now I'm going to show you a demo of all of the things that we talked about. This is the RUCKUS Analytics dashboard. As you can see, this is fairly information rich. And I want you to take your eyes and focus on this top right side, which is the severities. I want you to focus on these severities because this is exactly what we actually talked about right now, previously, anomalies converted into incidents. No human effort went into writing a rule or a threshold or any kind of alarm or definition in here to generate these things. Every day you come in, you will see some of these incidents, hopefully not P1s every day, but you do have that ability that this network is actually observing itself and telling the IT teams what can happen. I'll give you an example of a few different incidents here. This is the incident page. One of our customers, a large service providers, a lot of APs, 16,000 or so, they were having a lot of problems. The network was not stable. And they were trying a few different things. They tried exotic channel plans, 159.13 versus 1611, indoor AP placement in the hallway versus inside the residences. So they had conflicting data or maybe data that was not yielding to to a decision making. In that case, we went in and this particular page gave them very good insights. And some of the things that we found were very simple. 200 or more APs had speed mismatches. They were getting complaints from gamers, Wi-Fi was not fast enough. And the first thing they figured out was like, hey, the APs are not connected full speed. I'll give you one caveat before I show you more demo here. This is demo system. So if you see a lot of failures, some of them are created by us, and it has a lot of labs. So if you see a lot of Wi-Fi 6 APs or some data that doesn't make sense yet, it's running in the RUCKUS labs. So it could be that somebody is trying something. So that is one caveat I should have said earlier. So this is one of the incidents. So you can see that incident detail. This one is coming out at P3. There's root cause and recommendation that is all generated for every single incident that we have. The second part of the problem that we found in that particular, this is actually very common in other manufacturing site also had this problem, VLAN mismatches. So very easy in some sense, it's a needle in a haystack type of problem. Humans or machines configure switches or APs. And if you do that, it's possible that some VLANs are left over. And this is just a configuration mismatch. And we found a bunch of VLAN mismatches for this particular service provider, other customers. And this tends to be a more popular type of incident that we see. This one is more of a connection health, DHCP issue. And here I can see that this is a classic one. So people love to complain about Wi-Fi. It's a Wi-Fi's problem, right? So here I can already see from this failure that there is a ePOL was successful and DHCP discover went out and no offer came back. And that's somehow supposed to be a Wi-Fi problem. I don't understand how, but these are the types of tools that you need to prove to people that, okay, something is wrong. We accept something is wrong, but it's not a Wi-Fi problem. Let's start somewhere else. And this tool is tracking every failure of every client all the time. There's nobody doing a packet capture in there. Without packet capture, you can get this level of detail. And you can, of course, get a packet capture from the smart zone controllers. Then we also have, this one is a classic. What we also have is a site comparison reports. People try to experiment about how are different configurations, RF configurations doing. AB comparisons, if you want to do like 159.13 versus 16.11, there can be a lot of opinions that can come in. But if you want to capture data for a long period of time, you want to just set it equivalent, roughly equivalent floor plan, power levels and all that, and just run it. And over a period of time, we can prove it to them. It's like, okay, the RX failures, DX failures are higher in one versus other. That's why you should probably go with this channel plan versus the other. So we used this one quite a bit in that with that customer. Health is another one of my favorite tools. This will tell me what I want to look at. At an aggregate, look at this. There's 2,421 APs and 20,000 clients with 180 switches. I can already tell that my network is about 88% success rate and 415 milliseconds for average time to connect. Meaning if I have a client, I'm trying to connect, it's taking me 415 milliseconds to get an IP address. Now, on a Wi-Fi world, it's too slow. So I will probably click on that and figure out what's going on there. And it turns out that 70% of that latency is coming from the DHCP. And if you click a bit more, you can figure out exactly where it is happening. So apparently, now I did say that this was a test lab also. Somebody is trying to test open roaming and in Virgin Media here and in this zone. And that's where the latency is coming from, along with this Shenzhen zone. So in a couple of clicks, what I'm able to show you is a very detailed way of where the latency is coming from. And that's important and useful for people to use when troubleshooting. Here I'm showing a bit more in the failures. In the lower side of that page, we also have KPIs. And KPIs are interesting. We have 17 or 18 different KPIs that we track. You can, of course, set thresholds, in this case, yes, thresholds for your own site, because each site is not, no two sites are the same. You can't really set one KPI. And this is the reason we also got away from setting thresholds. I mean, how can an IT admin know that in a 20,000 AP network, what is the right what a threshold to set? It's very hard. And comparing networks is also very hard. So when we have this page, we have these 18 different KPIs, and we didn't stop just at the KPIs. In a couple of more pages, I'll show you how we are using this idea of KPIs. Turns out it's a very crucial factor when you're thinking about quantifying anything. We come to this idea of recommend. Yes.
Can I ask you a question about the KPIs?
Sure.
So the KPIs for Wi-Fi and the KPIs for cellular network, and you were saying you're dealing with a lot of service providers, are very different. Are you starting to see some trying to marry the two?
I'm so glad you asked that question. You're absolutely right. And when we say KPIs, that's a completely different vocabulary on the service provider side versus. So what I have done is mapped the KPIs from a service provider world to the Wi-Fi world. And I tell them that, like, when you're looking at this, availability is a big one for them. And a lot of different things map differently. And we sort of tell them that if you're tracking this KPI, it means you're looking at these three things. Okay. So yeah, we provide them the dictionary.
Is that mapping available at all public?
Not in this tool. Not in this tool. We do talk to the service provider teams directly.
Oh, okay. Okay.
But good question.
Okay.
So this brings us to what we are calling the recommendations engine. Recommendations engine is really about, we don't think there's anything wrong with your network, but we think we can optimize or we can fine tune your network a little bit more. Now, how do we do this? Because we remember that we talked about that idea about that graph, knowledge graph, and configuration that's coming in. We are able to take that and that performance and that KPI, put it all together and query that graph to ask the question saying, hey, if I tweak this parameter, will that parameter also increase or change? So that dependency, when we learn, we are in a better position to say, okay, we'll do it. Plus, of course, we have to add all the human and RF engineer background that we have. We obviously know that more channels, more non-overlapping channels will yield better performance, but the machine doesn't know. So we have to add that information together to generate this recommendations list. I'll give you a couple of examples here. And this is a good one. So this is a pretty basic one. Load balancing mode should be enabled. Okay, that's a good one, fair. But what is interesting about this is we say, what is this recommendation? Why is this recommendation being made? What is the potential trade-off? We also tell you what KPI we are seeing because of which we are making this recommendation. So wrapping all these four things around it is what makes it explainable. Question.
Do you have any feedback loop built into this that if you apply this recommendation, does it get validated that it actually improved that 76% to 80%?
Man, I couldn't have seeded this question. Yes. Yes, there's a feedback loop built in there, and it will look for 7 days. As sometimes changes don't take effect immediately. It will look for 7 days. And if the desired changes don't take effect for 7 days, it will revoke it. So that's a feedback loop. And there are more things that we are doing around that. Interesting. Thank you. That's a good question. That's the recommended AI. And this is actually one of my other favorite features. This one goes back to the idea of canary analysis. So, when you're making a large scale change to a network, there's always a risk, right? You take a risk for any software upgrade or configuration change. we have heard a lot of DNS outages here and there, and comes down to some stupidity of not applying the right change set. So it can happen in big networks too. And here what we have is before and after window. These two lenses are like before and after window. And these zone wireless LAN group, wireless LAN AP group AP are the different changes. So what this view is telling us is before you applied the change, your time to connect, and after you applied the change, your time to connect, you actually made it worse. But that same change improved the client throughput, and such is life. You cannot sometimes get everything that you want. And then we as engineers have to roll up our sleeves, figure out what's going on. Is this change any good? Should we be taking that risk? And what looks good on a Friday probably doesn't look good on a Tuesday, and that's it, right?
And how long before you see this being fully automated and taken over, requiring no administrator action to sort of make that decision?
This one is totally manual right now. We are doing the analysis. That's not manual.
Yeah.
But whether you want to roll out your change in your network is still a human decision.
Still human decision.
Yeah. All right. So this is actually a very good feature. I like it a lot. And this one is a bit of this one is also very interesting because places like this, events like these, right? These are high-profile events, and you want to validate that this meeting space has good Wi-Fi, and you can do that all remotely, orchestrate that. And what one advantage that RUCKUS access points have is the built-in radios. The client-serving radios can actually go into a virtual client mode, and they can generate synthetic traffic and test end-to-end. They can generate they can pass through all stages of connection all the way up to test to a speedtest.net server. And this is something that helps you get some confidence that that meeting space or that school or that college campus is actually ready with Wi-Fi and Wi-Fi works. Now, this one is called Video Call QoE. And I love this because we built this around the time we were all going into pandemic. Everybody was doing Zoom. Honestly, I had not used Zoom before that. And it just came out of the blue for us. And people were actually using Zoom and asking us questions saying, hey, your Wi-Fi is not strong enough for Zoom. I didn't understand those words at that time. Like, okay, let's see what's going on here. And what we did was we have a virtual network assistant, Melissa, and we have Melissa actually start a Zoom call. If Roel is complaining that his Zoom call is not working, then I'm going to be on a call with him, and Melissa is going to host it, and I can just ask Melissa to start the call, and we will be on a call regularly, like for like 7-8 minutes, and then Melissa will fetch the statistics from Zoom servers, and Melissa knows the statistics from our individual devices because it's connected on Wi-Fi. And we put 2 and 2 together. Is Wi-Fi good? Is Zoom reporting good? If one of them is not good, we know where to start. And this is one of these tests where video call QoE was bad, and the Wi-Fi was actually very good. RSS was good, SNR was good, client throughput, MCS, everything was good. But latency and jitter, latency and frame rate were bad. That's why the video call experience was bad. I'm going to hurry a little bit. We have what I would call the standard stuff. Webhooks, you can have Melissa right here, accessible from Teams, and we can from chat from Teams or Slack, all of those things are available. And I'm going to come back for a demo on the business intelligence slide. Oh, I need to show you this. This one is the data studio part. We have a lot of workflows built, which will help engineers uniquely, not uniquely, which will help engineers use the entire data set that we have with a very powerful visualization engine. And we have a whole lot of workflows that our customers and engineers can use. This is a super user tool, I would say, not individual. This is definitely powerful for troubleshooting large networks. Let me come back to my business intelligence section. And this is the view. If you see it here, I have actually moved from admin view to brand view, and it's called Brand 360. Now, I don't see all the details that I was showing you before. All those details have been sort of set aside because this brand person, the Yum brands, so they're not interested in operating a property of KFC or a Pizza Hut at location in Sunnyvale. No, they're not doing that. All they want to know is the network healthy? Are my customers happy? Guests happy? And is the network compliant? They want to be able to do that by properties, individual properties, or by partners, because they might have different partners doing different, owning different brands, operating different brands. They also have the ability of setting different SLAs, and SLAs, of course, can go by properties or partners. And this gives a level of governance, gives them a bit. They're not surprised on Twitter saying, "Hey, my experience on Wi-Fi in KFC in this place sucked." They don't want that. Nobody wants negative reaction at any places, negative press and social media. But this is giving them that uniformity, that global dashboard that we have helps them with this. The other big change that you will be seeing RUCKUS do is we are going very industry focused. If we know that there's a best practice, this data studio tool, that helps us saying, hey, this is what we have seen help us. This is the type of report that helps us in large public venues. Tell me what your airtime utilization is. And there's a report built for that. And the nice part about this report is you and I, as wireless geeks, might have a greater tolerance for pain, but the end customer may not. And I might have 30, 40 reports just built as a template. And I like it. I don't mind spending 2 hours doing it. But I can send that to any customer that's having a problem. It's a report template. And when they import it, it's their data that they see it. And now we are forming a RUCKUS community. And if you have this tool, I have this tool, we are sharing report templates and we are forming a RUCKUS community. And that is sort of the purpose-driven aspect of our business. And with that, I will conclude with my presentation. Question?
Is that, can you do it per user? Like in an educational environment, can I give my teachers a different SLA than I do manage my students?
It's the SLAs right now are by zones or APs, and it is really not at a per user level. Okay. It is at infrastructure level, APs, or you can have a classroom level SLA, things like that.
Oh, okay, so you're not seeing, because service providers do prioritize certain user groups, so you're not seeing that demand for that?
There is, but we do that from Cloud Path and Smart Zone controllers. We have that.
You're showing the Zoom test. Is that a synthetic test or a real?
No,
Zoom?
Real one.
Okay, so the statistics that you're grabbing, like jitter and all that, is that information you grab directly from Zoom? Because from Zoom, you can grab details from
no, you're right.
Meeting management.
No, it is real statistics from Zoom.
Okay.
And the reason we took 8 minutes there is Zoom gives us one sample per minute.
Okay.
So you're not that 8 minutes, only 8 samples.
You're not just looking at packet captures or anything. Okay.
No. It is real answers from Zoom.